After you eat a family-sized bag of chips or an entire footlong from Subway, you may feel pretty big. But I'm here to tell you, thankfully, you're nowhere near the size of some of the largest objects in our universe. But if you're not, what is? Before I roll the intro, I just wanted to let you guys know that this video is part of a collab with Zap Physics. After you find out about the largest objects in our universe, make sure to jump over to his channel and check out the smallest. Be sure to let us know what you think of the video down in the comment section below. The analytics really help us smaller channels. And let's jump in. Mankind has built some truly impressive things. The Empire State Building, the Sydney Opera House, the Three Gorges Dam, my faith that maybe the next Fast and Furious movie won't suck. All true marvels of engineering and willpower. But even these massive feats pale in comparison to what the natural world can put together. Mankind's tallest building, the Burj Khalifa, tops out at just over 2,700 feet, but you could stack 2.5 of them within the Grand Canyon. And mankind's largest building is Boeing's Everett factory, the production site for the Boeing 747 family. The building, basically one enormous hangar, has over 13 million cubic meters of space, bigger than 5,000 Olympic swimming pools, 7 MetLife stadiums, and the surprisingly spacious Ford Fiesta. But even this colossal factory wouldn't even fill up a tenth of the Chicxulub asteroid crater that helped wipe out the dinosaurs. But why limit ourselves to the only rock we've called home? The solar system is home to some pretty impressive feats. The tallest point you could stand on Earth would be atop Mount Everest. And nearly 5.5 miles above Earth's surface, you'd need several layers and oxygen tanks just to survive a few minutes. But on Mars, thanks to a lack of tectonic plates and no molten planet core, Olympus Mons tops out 16 miles above the surface of the red planet and covers an area nearly the size of France, making it the biggest mountain in our solar system. Now, getting even bigger, if I asked you what you thought the largest object in our solar system was, you'd probably say the Sun. Go ahead, I'll give you a few seconds to try to think of something more massive. If you stuck with the Sun, we couldn't really blame you. After all, it's what those posters on the walls of our 5th grade classrooms taught us to believe, and it's certainly a better guess than Pluto. The largest thing in our solar system isn't the Sun, but something that comes from it. Coronal mass ejections are a release of plasma from the surface of the Sun, and they can reach crazy sizes. They expand as they propagate away from the Sun, and can grow to nearly a quarter of the space between Earth and the Sun. In what would become known as the Carrington event, in 1859, a coronal ejection caused by a solar storm reached more than 94 million miles, hitting Earth and causing the largest geomagnetic storm on record. Let's just say things got pretty wild. Well, as wild as the 1850s could get. All over the northern hemisphere, colorful auroras danced across the night skies, reaching as far south as Mexico. That night, telegraph communications around the world began to fail. There were reports of sparks showering from telegraph machines, shocking operators and setting papers ablaze. And some telegraph operators could continue to send messages even after disconnecting their power supplies. According to the Lloyds of London, if a similar solar storm hit the planet today, it would cause more than $2 trillion in damage to the US electrical grid. But move beyond our solar system, and now we're really talking the biggest of the big. At the center of our galaxy sits the supermassive black hole, Sagittarius A. At 4.1 million solar masses, or 4.1 million times larger than our Sun, it's the most massive object in our galaxy. But as far as black holes go, ours is near the runt of the litter. 53 million miles away lies the Chad of all black holes, the supermassive black hole at the center of the MESAR 87 galaxy. It's 6.4 billion times the mass of our Sun and would stretch across our entire solar system. By the way, this was that famous black hole that was photographed last year. But the biggest of the big is yet to come. At approximately 10 billion light years across its longest length, the Hercules Corona Borealis Great Wall, also known as the Great GRB Wall, stretches across 10% of the observable universe. For comparison, our Milky Way galaxy only spans some 100,000 light years. Discovered in 2013, the Great GRB Wall is a massive superstructure of gas, dust, and dark matter, containing billions of galaxies, and more than twice the size of the previous largest known object, the huge Large Quasar Group. Now you may be wondering, if this Great Wall contains billions of galaxies, why does it count as one big thing, and not a bunch of smaller but still massive things? By that logic, couldn't you just arbitrarily add more and more galaxies together to get an even bigger object? Well, you're not wrong. But what makes the Great GRB Wall unique is that this supercluster is home to a group of tightly packed gamma-ray burst sources in much higher abundance than we see in the normal background of space, and it's separated spatially from everything around it. Gamma rays are the most powerful type of radiation in the electromagnetic spectrum. This super high frequency radiation is emanated only in a handful of stellar events, like supernova, collisions of neutron stars, or by especially fast spinning black holes. The structure is even so large, it seems to contradict our theories about the evolution of the universe. The structure is 10 billion light years away, which means that we're seeing what it looked like 10 billion years in the past. And since the universe is 13.8 billion years old, give or take, this means that this massive structure had to form in the first 4 billion years of the universe, and our modern understanding of physics can't explain how such a massive structure formed in such a small amount of time. Even Istvan Horvath, the man who discovered the Great GRB Wall, says he has no idea how the structure could have formed in that amount of time.
So why exactly does this Great GRB Wall not seem to fit into our theories? I'm here from Zap Physics to try to explain a little bit more about this question. It all comes down to what's known as the cosmological principle. The basic idea of the cosmological principle is that the universe should look the same no matter where you are or which direction you look. Now, I know what you're thinking. This can't be true since we see different stars, planets, and galaxies all around us. The caveat to the cosmological principle is that it is only expected to be true above some very large length scale. This is due to the fact that we expect the universe to have been very small right after the Big Bang. During this time, quantum fluctuations created tiny spots of non-uniformity. Then, the universe went through a period of rapid inflation, stretching these small fluctuations into the galaxies and clusters we see today. However, if the cosmological principle is correct, these fluctuations, and thus the corresponding large-scale structures, shouldn't be too large. The Great GRB Wall is about 10 times the most well-accepted theoretical predictions, and so it seems to contradict the cosmological principle. But this isn't the end of the story. Quantum mechanics is inherently probabilistic, meaning that there would be some chance that a larger than expected fluctuation that would result in something like the Great GRB Wall could occur. However, this likelihood goes down the larger the object is and the more of them there are, so whether or not the Great GRB Wall is actually compatible with the cosmological principle and the theories of inflation still remains an open question.
For now, the largest structure in the universe may just be its greatest mystery. Like I said at the start, this video was done in collaboration with Zap Physics, a channel about, you guessed it, physics. It's a great channel, and this is my first collab, so I'd highly recommend checking out his video here on the smallest object in the universe. Have a great day, and remember, there's always more to learn.